Hey guys, Victor's our channel is with you, and today I will tell you about how the old games with pseudo-3D graphics were arranged. And we will also write our own simple Wolfenstein 3D version in 180 lines of code. Enjoy watching. We all remember the good old games like Doom or Wolfenstein 3D, which in their genre were pioneers of three-dimensional games. Now such graphics seems already quite outdated, because in modern games it's so realistic that it's sometimes difficult to distinguish a computer game from a movie. For example, here is a 3D simulation. In my opinion, it's so incredibly and coolly made that not everyone will immediately determine whether it's a real photo or a computer model. To create photorealistic graphics, a lot of cool and complex tricks are used to make beautiful lighting, realistic shadows, reflections and many other details. To make you understand how much calculations happens when rendering modern game, I will give my favorite GTA 5 as an example. For rendering only one frame, 4155 draw calls, 1150 textures and 88 rendering goals will be required. But for a comfortable game, you need to draw 50 or 60 times per second. Powerful modern graphics cards allows us to make all these calculations, but before that, computers could not even get close to such results. Therefore, programmers had to come up with methods for creating 3D images that didn't require large computational costs. The founder of first-person shooter genre was Wolfenstein 3D, a computer game developed by id Software. One of the main creators of the game was John Carmack, who wrote the engine. John developed the core of new game engine in just a month, adding several innovations from the Catacomb 3D engine, including supports for doors and decorative elements that could be placed not only on the wall. However, he mainly focused on making the game smoother and faster using high-resolution graphics. It's really interesting that at the time of development he was only 21 years old, and he created his first game at 19. In my opinion, this is very cool and such stories always motivate. I will not consider other games that use the same technology, but only talk about how to create a 3D effect that doesn't require large computational power, and how this can be done now in just 180 lines of code, using console graphics. The first thing you need to understand is how to store the map that we will be running on. The map is stored as two-dimensional array, where the first index denotes the coordinate in x and the second in y. Knowing the width of the map, we can store the two-dimensional map in the form of one-dimensional array as follows. We will use a grid to indicate the wall and a dot to indicate empty space. You may notice that this is not real 3D, because the map fits in two-dimensional space. Of course this is true, but we will create the effect of three-dimensional later. On our two-dimensional map, we can walk and change the direction of our view. That is, all information about the player in the simplest case can be stored in the form of three variables: his position in x, position in y and the direction of view. Direction of view is the area of the angle at which the player will see objects. You may notice that there are objects that the player sees in whole or in part, but there are those that go beyond the scope and will not be displayed. Controlling the player will be very simple. The keys W and S will be responsible for changing the position along and against the direction of view, and keys A and D for changing the angle. That is, use the A key to turn left and the D key to turn right. Making such control is very simple and takes no more than 50 lines of code. On my website, link will be in the description. You can read in details about how to do this. Now, let's move on to the main part, building the illusion of three-dimensional image. We will build the image in two cycles, changing the coordinate and x direction about the outer cycle and the y coordinate in the inner one. I remind you that in the console, as expected, the text is output from left to right with a downward shift. Therefore, the grid will look as shown on the screen. We will split the image into vertical strips. You need to find the distance from the observer to the object that lays into the strip. The wall is bigger, the smaller the distance to it. The observer has a certain angle of view for theta into which objects can be seen. We will try to find the distance to them. At the beginning we have a direction in which we want to check for an object. After that we cyclically take small steps in this direction. In the end, two results are possible. Either the beam collided with an object or it went on an endless journey. In order not to fall into an infinite loop, you need to limit the radius of visibility. If the wall doesn't lay within the radius of visibility, then we will perceive this as an absence of the wall in this direction. That is, to build the image, we build vertical strips. In order to determine the size of a section of the wall that lays in each particular strip, we must determine the distance to this section. The observer starts beam with a certain step, pathing through the entire viewing angle. The direction of the beam to build a specific strip on the screen is based on the fact that for the entire passage along the x-axis on the screen, you need to completely pass the theta viewing angle. The farther the wall is, the less space it should fill on the screen, and the more space sky and earth will fill. This method of determining the distance in a given direction is called raycasting. In fact, we now have everything in order to create the illusion of 3D. Having the distance to the wall in this direction, we can calculate its height relative to the screen. But How to do that? You need to understand how the relative height of objects changes when the distance to them changes. From simple geometry, we immediately obtain the dependence of the cat's projection height on the screen on the distance to it. If the distance to the cat becomes very large, the projection size decreases and the sky with the floor takes up almost all the space on the screen. If the distance becomes small, then the size increases rapidly and the projection takes up more space on the screen. To draw a wall, you need to set two coordinates in y. The first where the wall begins and the sky ends, and the second where the wall ends and the floor begins. If you made these 2 points symmetric with respect to the center and height, takes 1 meter to the screen and the wall size equal to the height of the screen, you get the formulas that you can see on the screen. The area between the beginning and the end of the wall will be painted over with while symbols. If you reached this point and didn't turn off the video, then I can congratulate you, because everything that I just said it's not easy and it's quite difficult to understand it right away. But now you understand the principle of constructing a pseudo-three-dimensional image. As a result, we got the following. In our game you can walk and look around. All walls really seems three-dimensional, but it's still difficult to navigate. I propose to draw a distant section of the wall with less noticeable symbols. We will do the same with the floor. Now the game looks much better. The only thing that could be added is a reflection of the edges with a specific symbol. For example, a vertical line. This is a bit more delicate part, but try to focus. Let's say that we are looking at some part of the wall. To build, we emit a lot of rays and determine the distance. Now we have ribs, the places that we want to highlight. Among the rays that we released, there are those that seems to look at the ribs. That is, the angle between this beam and the beam leading exactly to the edge is very small. Mark these rays in red. Those places in which these rays lead will mark as an edge. The only thing is to highlight the necessary rays. As we know, the angle between two vectors is minimal when their scalar product is maximal. From all rays, we select those that give the maximum scalar with the edges rays. Yes, I know, it's quite hard to perceive. But if you don't understand something, just rewind the video. As you can see, it has become better. It's easier to navigate because three-dimensional objects are now easier to distinguish. We output only two nearest edges, but often the player must see three edges. The fact is that adding a third one introduces an artifact in the form of display of those edges that we shouldn't see. It's a problem that can be considered in the future. In fact, that's all. We have a simple walker in which you can navigate. Naturally, the graphics of such game can be greatly improved and made everything much more beautiful. But the purpose of this video is to introduce you to the basic principles without going into deeper and technical details. As I said before, you can read about the creation of this game on my website or visit the great video from One Lone Coder channel.
It's a little first-person shooter engine, and it's very primitive because I mean it's rendering everything using ASCII characters. You can see we can navigate around. I can turn the character. We can walk down this corridor. I'll just rotate us there, face the other way, and we can walk up and down the map. You can see a little map in the corner. The P indicates where I'm currently stood in the maze. Have a quick look outside here.
All links will be in the description. Special thanks to my sponsors on Patreon. It's very difficult to make videos without supporting at all, and I'm really glad that I have you. If you like this video and you learned something new from it, that's fine.